happy to talk about the third comparison. This is another most important fundamental of grade 3. I will talk about design patterns in grade 3. Grade 3, the goal of grade 3 is in the near future, I hope this system can be evolved to a new programming language. That means we use this language to develop any distributed system. Not for the enterprise system, enterprise level based system, but also focus on the internet-oriented distributed computing environment. And for this goal, for such programming languages, we need to construct. We need to know the code structure, because my system based on Java. I use a lot of Java. I program a lot of Java code. Using Java code, I can propose a bunch of API, distributed perimeter API, and many advanced API. At the same time, I noticed that all these APIs can be constructed in similar design patterns. That's a very important discovery, right? I think if we need to construct a new distributed programming languages, this language usually should be constructed over existing language. So we need to encapsulate existing mainstream languages with a new syntax. So developer need to use a new syntax semantics to program a distributed system. But this syntax and the semantics should be transformed to the low-level language. In my case, it should be transformed to the APIs and I created, right? If so, we need to know how to generate this code. We know a machine at this time, machine can only generate some code that have a predefined a restricted format. The format should be this machine can only generate well-formed code. Well-formed code is different from people, right? Software engineer, human beings can create code arbitrarily, right? Usually, if we ask, for example, we ask people to create a code, create a server, a simple server using Java, JSE, such code looks very different. Different people have different code structure and different ways to support the network programming and the network connection, to different way to manage the resources of network, input output, and a different way to support the concurrency, right? How to manage the threads, how to at least even the algorithm is same. The code looks different. This is a common sense. Different people have different solutions in terms of code structure. The design pattern I mentioned here, the design pattern in this here, I mentioned here, is a code level design pattern. If you read some classic book about software engineering and design patterns, there are a lot of other design patterns, but those other patterns, not a lot of code patterns are not code level design patterns, or even we can program some code to illustrate the design patterns, this code usually cannot be used directly. We have to just follow the main idea and create our code, and in a similar way, but we cannot use the code directly. But in my case, that's different. We can use the design pattern I propose directly. We just modify some specific variable, specific messages, as well as specific thread, but the overall architecture is the same. We can show that in the later cases. So at least I noticed that my discovery is that heterogeneous distributed system have the compatible, similar, or homogeneous code level design patterns. Because we have no time to discuss this issue clearly, and we have so in the near future I will prove this this principle, and this I think this is a very important discovery. I create a lot of code, so I know I propose this this idea. So if this is correct, that means even the distributed system is different. There are a lot of various distributed systems. We have talked about in the previous classes, right? There are a lot of different architecture, different protocol, different data, the high volume data, lightweight data, the centralized architecture, decentralized architecture, the topology difficult, and some system is just based on the machine algorithms, but some system based on the human behaviors. We need to run this system based on the human influence. So the different type of distributed system. Fortunately, though all of the code, all of the system have the similar code structure. That means we can generate, if so, that we can use some simplified or just a couple of a limited number of syntax or semantics to describe various distributed systems. That's very important discovery, right? So that's why I written here the statement here. For a new programming paradigm, it's mandatory to find the code level design patterns in the old language to cover all the scenarios of the specific computing environment it concentrates on. Then the compiler can generate the code following those patterns upon new languages. Now the new language is still not created. I'm still working on that. But most of the fundamental APIs and are created. The principles are also almost complete. So I think that's the only way we can create new languages. If we have no such discovery, if we cannot know, we are not sure whether the code structure for different distributed system is different or not. We have no such idea. We cannot confirm that. We have no such conclusion. It's impossible for us. To create a new programming language to generate all the to development all the distributed system with a new language. It's impossible because this transformation from the new languages to the low level language, the transformation is impossible because machine cannot generate the arbitrary code. The machine can only generate well-formed code. So that discovery is very, very important. However, you know that if you program with Akka and Go, at least at this moment, I had never read any documents or papers or books talk about that. Akka book, Go book, I read a lot of them. Almost all the book published and all the papers published, I read all of them. However, I don't think Akka and Go have this issue. Talk about this issue. If so, how can we ensure this is a new language, is a general purpose language? Because I think Akka is based on Java for sure. Go must created with C++. But this transformation, how to do this transformation? Go should be transformed to C++. Akka should be transformed to Java. How to do this transformation? If we have not discovered the code structure for various distributed patterns, we cannot prove that. If we cannot know, we cannot ensure the code structure is similar or not. So that means this transformation is impossible. Otherwise, if so, that I think Akka and Go is not general purpose language. It's another why I don't think they are not general purpose language. Why I say my solution is good enough, right? Is can be claimed to be a generic programming language. In my system, there is another foundation. I call it SPRA. SPRA stands for Steady Patterns for rich APIs. That means although the API is rich because there are different functionality, different solutions for various distributed system, so the patterns should be different. The API should be different, but their patterns are similar. I will show the code and show details how to why that's correct, but I have no time to talk about that this time. So I think my mathematic background is not enough, so not good enough. Maybe I need to ask some other colleagues to help me to prove that. But based on my experience, I'm sure that be correct. Another simple proof maybe is that I invent distributed primitives, right? Using distributed primitives, we can create any distributed system. We can create any advanced APIs we talk about in the previous classes. If so, that means any distributed system can be generated in the code formed by distributed primitives. Distributed primitives contains not only some APIs, but also contains some design patterns. So that means distributed primitives can form the cell, can form the minimal component. Minimal component of the system. All the system is constructed based on the combination of the minimal components using distributed primitives. If so, that is a one of the pro, but I'm not sure whether this pro is good, is sufficient or not. I will ask some other people. Maybe if you are interested, maybe we can work together on this issue. But I'm not right at this time. Yeah, I think it should be good from my point of view. But I'm not sure whether further strict proof is required or not. But I think this is the one what I understand this issue. So I'm still here. I listed some patterns here. It can prove what I have done, and but as this pattern still in the procedure to be filled. So in the next time, in the near future, I think maybe this technique can be accepted by industry, and not only as well as academic. I'm still working on this technique, and this is just some simple, simplified, a brief introduction about my system. So in the next classes, I will explain all the techniques in detail with code, not just a presentation. Okay, that's all for today. Thank you so much. We'll talk about this the second class. The second class will maybe we have still some time, and I can just show how we can start it. Okay. In the next class is I will talk about distribute. We can start from distribute primitives, because this is one of the important fundamental techniques. I will show how to create what those API looks like, right? And also I will show you how to program with these APIs, and I will program some simple system using these APIs and design patterns only, and then you can understand the concept of distributed primitives. And in the following classes, I will still working on those distributed primitives, but I will create a more complete distributed system. And some new advanced APIs will be created, some new distributed system will be created. And I think you will understand the technique more deeply, right? Deeply. I think if I got some, you have some questions, you can ask me. Send me email, and we can keep on working. Maybe you are interested. We can working. We can work together, right? Okay, today is it's a short class. Okay, doesn't matter because we finished the topic. So in the next time, we'll continue to talk about distributed primitive. Thank you so much for today.